Hello, my name is Karsten and I'm going to talk about how it is to work as an optimization consultant. So a consultant is somebody who gets paid to do a job, to solve a problem. And usually you're either part of a large company, and in which case you are what I call an internal consultant, or you are an external consultant, so you work with a company and that company gets hired by another company to solve a problem. In this talk, I'm going to talk about all the issues I've come across with being a consultant, but I will not talk about, when I say issues, the problems I encountered, the optimization problems. I will talk about everything else that is around that. And these are just things that I have experienced in these 10 years I've been doing this job. And it's definitely not an exhaustive list, and you might get lucky and actually get none of these issues. Or you might be like me and just encounter them just time again and again. Every project starts with the first talk. There's a moment when you and your client come together and you're listening while they're describing what's the problem they want to be solved. And it happened to me a few times that the problem described was not optimization. They were under the impression it was because they were maximizing something. And as an example, they were looking into how to do trading better. So they were looking for a trading strategy, and their objective was to maximize money. And although there is an objective and there is a decision to be made, if I have to buy those shares today or not, or should I sell if I own them or not, since we don't know what will happen tomorrow, we cannot evaluate our objective, and therefore it is not an optimization problem. It is first a machine learning problem where we want to predict what the potential value will be, and once we know the value, we can then apply optimization. In this particular example, we actually asked them, how do you do your current trading? And they told us, they told us effectively how they're doing it. And then we went back and applied this, looked at the historical trades for the last few years. And because we had all the prices, we created an optimization model that was solving this problem as if it had a perfect prediction of the future. And this gave us an upper bound. How much money could we have made with the perfect predictor that is possible? And then it turned out that the gap between the money they made and what we could have made was not actually justifying that the project existed, because the value was simply not there. Value is a really important work in industry. It's effectively representing what is the benefit of if we do this. And if there's no benefit, then the company, why would it do it? It would cost them money, and probably more money than what they would be making from it. Now, value doesn't necessarily always mean money. It can also be time saving, which effectively also comes down to money. If somebody doesn't have to spend a week to create a schedule and we can just do it in 3 hours. But it can also be, for example, just that the schedule that we have is more robust because we have the power of computation, and we can also ensure that our schedule, for example, is compliant with certain laws and rules. And that is also a major benefit for the company. Now, how do we find out what the value is? That's not so easy for optimization. For that machine learning problem I talked about earlier, usually we can use optimization to establish what the best outcome would be if we had a predictor. And then we can simply look at the baseline, how is it done at the moment, compare it to, take the difference, and we have a value. For optimization, it's tricky because you are not always able to find that quickly, and you don't want to delve too deep into the problem, spend months just getting the value. That's not worth it. So we end up with a very broad estimate on a back on the envelope calculation based on initial analysis of the data, and then we usually say that shouldn't take more than a week, and then we make a decision whether or not the project is a go-ahead. This brings us to the next potential area of issues. We need data. Do we actually have the data? Unfortunately, it's happened a few times that we first talked about the problem and the client presented it, and then it turned out we actually don't have the data, or we don't have access to it, or the data is in a proprietary format that we can't read, and we would need to pay thousands and thousands of dollars for a tool that can read it. And this is another reason to quickly reject the project. If data is not there, there's nothing we can do. And there's also the other interesting question in it. What actually is the necessary data? So in this initial talk, we try to establish with the client that a list of potential data sources and what they mean and why they would be important. And this is already helpful for the client itself. Usually they never give it so much thought. They don't know exactly how we actually need this. Yeah. And then when we go and talk them through, and they basically do the talking, we just do the questioning, they realize sometimes already that we probably don't have this or that anyway. And then this can also easily be the end of the project. Now, another aspect we have to establish in the first meeting is usually how can we establish that the solution we produce is actually correct. So with that, you have to be aware that it happens about, I've got feeling 99% of the times that the problem we presented originally in that first meeting is not the problem we actually end up implementing and solving. So the clients simply are not fully aware of what the actual problem is. They're learning as much about it as we do as we continue on the project. And so right in that first start, we're trying to establish first, we're trying to help that we can actually iterate faster and more efficient. And that means we need to have access to a subject matter expert, somebody who knows if we give them a solution, they can tell us if this makes sense or not. And they can then quickly tell us why it doesn't make sense, so we can amend and change our rules. Otherwise, you will waste a lot of time just producing things that potentially has no value to the client because it's not actually the problem they wanted to be solved. And that means effectively we're trying to establish with the client right from the start, bring it on paper, how can we validate that what we're doing. If we can't figure out a strategy, which always depends on the problem we are working on, then there's no point in doing it. There is no way they will trust the solution because it is not validated, and there is no way we can actually create any more trust because we had no chance in establishing that this is really what I wanted. And the main reason for all of this to happen is that although under the hood, a lot of these problems are very close to what you learn in university or what you read in books. Like, for example, this is a bin packing, this is a routing problem. But when you look into the details in industry, there's a ton of more constraints and rules involved that really have to be correct, and otherwise you will not have any value created for your client. So as an example, we had a problem that had about 100 different constraints, and on the simple basis of it, it was just an assignment. You have employees, you have jobs, you assign employees to jobs, so that jobs had certain time frames that had to be done and it consumed a certain amount of time. But with 100 constraints and a very complex logic with a lot of special cases, there was simply no way that this was initially correct the way they described it to us. And there was simply no way for us to evaluate that this was actually really true. So we needed an iterative process where we gave up a new solution, and then the client simply had to look at that solution. They spent about 1 or 2 days on it, and then it told us everything that was wrong, and then we simply came back to them. They came back to us, and then we had to fix it and present a new solution a week later. One way to help clients to validate a solution is by developing metrics. This is usually something that does not happen on the first talk, but it comes over time. And this is especially valuable and important if you have large projects like the one I talked before, with a lot of constraints, a lot of logic, and you give them a solution with potentially thousands of entries. And even for them, it will not be trivial to just look at it and say, yeah, this is correct or not. So metrics is effectively a way to help them understand what's going on. An example for a metric would be if you assign employees to jobs, you could simply then print out a metric. What's the average number of hours an employee is working? Or what is the average number of employees on a specific type of job that is reoccurring? And these kind of things are also helpful for yourself, because once the client sees the metrics and you usually discuss with them what kind of metrics they want, or you propose some, you can automate the kind of metric checks. They will tell you, we usually look at people shouldn't work more than 50 hours a week. And then you can implement it. And if something goes off and it suddenly says 100 hours, then you know there's high chance that you have a bug somehow, and whatever you recently changed or implemented caused problems. And then you don't just need to wait until the client comes back to you. You can fix this immediately, and therefore just iterate faster in a safer manner. And the next point is a very big one, and that's data again. But this time it's about the issues of the data. And I have not seen it that data doesn't have issues. The problem of this is that you can do a preliminary analysis and you probably figure out a couple of issues that come in, a couple of things that totally don't make sense. Say you have employees expected work time and it says suddenly, they can work 1,000 hours a week. But then there's a lot of subtleties that you cannot tell, because only a subject matter expert would know. And what usually happens is that you use this data and you produce a solution, and then you give it to your subject matter expert, and they validate it, and they come back to you and say something is wrong, and this is what it is. And then you're faced with the challenge that you have to figure out, is it the data or is it your code? Do you have a bug? And it is really important to have solid software design in this moment, because it will help you to iterate faster over in your own code and figure out where the issue lies and why the solution came out the way it is. And once you identify that it is the data, usually you should do two things. You should put an automated checker in your code that wherever after you receive the data, immediately alerts you of these kind of issues. Now there's two different options here. Either they tell you that they're going to fix it on their end. In this case, this alert should be an exception. It should immediately stop any computation, because this should not happen. Or they tell you how to fix it. For example, leave out this number or change it to this. In this case, you should do this, automate this code, but at the same time also log that this happened. Because then if later they come back to you in some solution and say, well, we gave you this person and this person is not working 70,000 hours a week, how's that possible? You can tell them, yeah, I wrote this automated data checker and it logged that it changed this value to this. And you might want also, when you write this checker, write in the code and as a comment, log in there when they told you this and what feedback round it was. And so that you can tell them, here, this is the email on this day, you sent me this email, and that's how that's why I implemented this change. To summarize what happens in the first talk, you want to have a high-level problem description. They come with something and they tell you what's in their head. You want to establish what the value of the project is, or at least you want to figure out how you can establish this. Now, this is only relevant if you work for a large company and you're like an internal consultant, and because as an external consultant, they're going to pay you to do this, and they must have already figured out whether or not it's valuable for them or not. It's up to them to decide. In the first talk, you want to figure out how we can validate the solutions. You want to have talked with them about it so that they're aware it's important, and that they might also figure out potential issues that can come along with that. And you want to talk about data, especially how can we get the data, what kind of data will we need, and do we have enough data to actually validate what we're going to do. Now, what comes next is an iterative process. You implement parts of the problem, somehow implement a bit of data validation if you already can, and then you provide them with a solution. And it doesn't have to be a full solution. It can already be very valuable if you just implement parts of it. Say they give you 100 constraints and you implement just 20. Instead, tell them, I just implemented those 20. Can you check and see any of these issues with that? And then you get feedback, and in most cases you will get been told there are some issues. And then you have to figure out, okay, if it's a data issue, you want to create a data issue checker. Put that somewhere in your code, run that automatically before you run your optimization. And therefore you will immediately get feedback if something went wrong, and you can give them feedback if something changes in their data. Or if it's a problem formulation issue or a bug in your code, you just fix it. And then you want to add a new solution checker if you can for the issue they have provided. So what it means is that they told you, well, we figured this out because these numbers are a bit off in the solution. Well, you can implement that, and then you can either write a log for it with a warning, or if it's very clear that's an error, you can put an exception there. And this is very much an iterative process. We used to do, depending on the project, really 1 to 4 weeks of the feedback, but it varies a lot in between the projects. Sometimes it's just days, hours. You give them a new solution, and it also heavily depends on how complex this solution is, because how difficult this is for them to actually validate it. Now, one thing I haven't talked about that is runtime, and how do you actually choose which algorithm to use? And I always aim for the most general kind of a solver that I can think of. It's like mixed integer programming, for example, or constraint programming or nonlinear programming. They have all great solvers, and you don't have to implement the details of the solver, you just implement your model. And that is great because it gives you this flexibility that you need to adapt to your problem description. As I mentioned multiple times, it's just changing time and time again. And so you want to be fast and flexible to adapt in your problem. Imagine that you actually implement a super great algorithm that works perfectly and super fast on your first description that you've been given, but then the problem changes. And suddenly a nonlinear aspect appears in what previously looked like a polynomial problem even. Yeah, then you have to throw away everything and you have to restart, and you waste a lot of time. And therefore, I always recommend using MIP and all the other great technologies that are out there. And only at the end you can actually think of, okay, now we actually finally have come to the point, they found no more issues in the solution. Now, how do I get it as fast if I need to? Sometimes you don't even need to. Sometimes MIPs are already fast enough. And now you can also use your MIP, for example, your solution that you already have, to validate your other code. This allows you to iterate heaps faster as if you would be using a subject matter expert, and you can automate a lot of that as well. And last but not least, it's this is actually then the most fun, because you can really just write this special algorithm. You can find those valid inequalities that make your MIP run heaps faster, but you don't have this pain anymore that you suddenly have to take them out later because they tell you, no, well, actually, this is not really what we wanted. And I have been there. I did these things in the beginning, and it was not fun, not at all. So coming almost to the end, what is it to take away from this? Check that your project is valuable. Make sure you somehow have a feeling when you're working on this that, yeah, there is actually something you're creating for the business. Ensure that the approach is robust. Now, it can easily happen that you, for example, come up with a nice idea for an approximation to solve your problem, but in the end, the approximation, the solution you have, doesn't translate back into the real world. So whatever you're doing is not generally robust. It might have worked for the one instance, but you have to ensure it works all the time. Because at some point you have to give it up, you have to let it run in production, and then this is when you have probably no control anymore. Ensure that it's a strategy to validate the solution. Very important, because otherwise you will never actually create the value you have projected. Almost no project starts with the correct problem description. I mean, that's very clear. And no data is ever without issues.